So in this video we are going to look at how to solve some exponential equations. So in our most simple case of solving an exponential equation, you basically just have a variable that is in an exponent. So we are going to use the idea of logarithms undoing exponents in order to solve exponential equations. Since this has a base of 3, that will be the base that we use throughout the course of this problem. I am going to take the logarithm of both sides, or I can just change this into logarithmic form. I will show you what I mean by both of those things. So if I take the logarithm with a base of 3 of both sides, I get log base 3 of 3 to the x equals log base 3 of 7. Using my rule of logarithms that says I can swing an exponent down and make it into a coefficient, this side becomes x log base 3 of 3 equals log base 3 of 7. Whenever the 3 to what power gives us 3, 3 to the first power gives us 3, one of our rules said this is just 1. So on this side I just have x, and on the other side I have log base 3, 7. Now that answer is fine unless I specifically ask for a decimal approximation. That is what I expect, and what I want from you is just log base 3, 7. You can plug that into the calculator and get an actual answer for it. So I could hit Math A using my log base 3, 7, and see that this is approximately 1.77. But really the answer that I am looking for there is this one, right? So 3 to the x log 3, 7. Now at the beginning of the problem I mentioned that you don't actually have to do that. There is an alternate kind of way of doing this problem, and that's just simply changing this into logarithmic form. If I've got that 3 to the x equals 7, then log, there's my base, 3, 7 equals x, because 3 to the x power equals 7. So you can use that loggy froggy idea to simply take the more simple problems, and by putting them into logarithmic form rather than exponential form, the answer to the problem appears, or it just kind of happens. E to the x minus 1 minus 5 equals 5. If we have slightly more difficult exponential problems where there's more stuff going on, the idea is to just isolate that exponent as if it was just a variable, meaning I'm going to get this e to the x minus 1 all by itself. I'm going to do that by adding x by adding 5 to both sides. That will give me e to the x minus 1 equals 10. And now if I just take that and change its form, so using the natural log, that means there's a base of e there, natural log 10 equals x minus 1, because e to the x minus 1 equals 10. Adding 1 to both sides, we get that x equals 1 plus the natural log of 10. So the idea there is to just take the function, take the equation, isolate the variable in terms of get whatever base and exponent you've got by itself, and then use logarithms to complete the problem. Now, really the only way these problems get a little bit more complicated is if we have a problem that has two different bases in the problem. And really all you've got to do is you have to pick a base and stick with that base throughout the problem. As we work this, we will see that this gets a little bit uglier than it does when there is only one base, but so long as you are paying attention and keeping things straight, it really should not throw you for all that much of a loop. Let me show you what I mean by that. So let's take this 3 to the 2x plus 1. I'm going to take logarithm base 3 of both sides, primarily because it's on the left-hand side, and that's just what I decided to go with. Could have just as easily done a log base 5. So I'm going to go log base 3 of 3 to the 2x plus 1 equals log base 3 5 to the x minus 1. Now what we're going to find here, we swing down the 2x plus 1. Log 3 is 1. So this side, where I have the base as the same, really simplifies pretty simply. It becomes 2x plus 1. The log base 3 just disappears. The other side will stay a little bit more complicated. Over here we end up with x minus 1 times log base 3 5. This log base 3 5, that's just a number. We don't know exactly what the number is, but it's a number. So I'm going to take this log base 3 5, I'm going to distribute it. That'll give me 2x plus 1 equals x log base 3 5 minus log base 3 of 5. Since I'm trying to solve for x, I need to put everything that has an x on one side of the equation, everything without an x onto the other side of the equation. So I'm going to subtract x log 3 5 from both sides, and I'm going to subtract 1 from both sides. So on this side we have 2x minus x log 3 5. On the other side we have negative 1 minus log 3 5. I factor the x out of both of these. That gives us x times 2 minus log 3 5 equals negative 1 minus log 3 5. Divide both sides by 2 minus log 3 5 divided by 2 minus log 3 5, and that is your final answer. So notice as we went through, this log 3 5 that showed up, it just kind of stuck around. And we used it just like it was an x, just like it was a y, just like it was any other number, adding and subtracting it to both sides, factoring. But in the end, that's about as hard a problem of exponential functioning as you're going to get.